Okay, guys, hi. I had some questions about the math of the Diffie-Hellman exchange, so I'm going to go and run through another example with you. Feel free at any point to pause the video, try it on your own, and then check your work. I'm just gonna go through the whole thing, but it might help you if maybe you watch Alice's portion of the exchange and then stop and try Bob's. Um, or you might need to watch the whole thing, go back and try it again. It's up to you, whatever you need to do. But let's start with our prime number. And in this case, that's going to be 13. And we're going to get a generator, which is a number that's co-prime to 13. And we're going to pick 6. Now remember, these are numbers that everyone in the world can see. So Eve, who is trying to figure out your message, is going to see these numbers. Okay? Alice wants to send a message to Bob. And they have these two numbers that they're going to use for their algorithm. And Alice is going to use the algorithm, where she takes her generator G, raises it to her power, whatever her secret number is, mod 13. Bob's is going to be a little different. Bob is going to take the same G, but raise it to his secret number, mod 13. So the only difference is the power that they're raising these numbers to is going to be different. Okay. Now, here we go. So let's say Alice chooses the number 4 and Bob chooses the number 5. So Alice is going to take 6 to the 4th power and mod 13. So when I work this out, I'm going to use the order of operations. So exponents comes before division, and mod 13 is telling us that we need to divide and take the remainder. So I'm going to start with my 6 times 6 times 6 times 6. When I multiply that all out, I get 1,296 mod 13. So here we go. What this means is I'm going to take 1,296 and divide it by 13. Okay, can't go into 1, can't go into 2, because 192 9 times. And 9 times 13 is 117. So I subtract. This is just the division algorithm that I'm using now. Now your computers are normally going to do this for you if you're doing it on the computer. Obviously, you don't do this every time you want to send an email to your friends, but here we go. We are going to be using small enough numbers that we don't have to worry about that. Okay, so 16 minus 7, that's 9. That's my remainder, 9. That's the number I'm going to send across to Bob. And remember, everybody out here in between, all those Eves, they can see that 9 coming across. While Alice is doing this, or when Alice sends it across, Bob can be doing his algorithm. He's going to use the same generator, 6, because that's what we're sharing out in the public for everyone to see, to the 5th power, mod 13. Okay? So 6 to the 5th power means I'm going to do 6 times 6 times 6 times 6 times 6, which is 7,776 mod 13. So I'm going to take 7,776 and divide it by 13. Okay, so let's do this. Let's try 5. 13 times 5. 5 times 3 is 15. Carry the 1. 5 times 1 is 5. Plus 1 is 6. That should work. Okay, so can't go into 7, but it can go into 77 5 times. That's your 65. 7 minus 5 is 2. 7 minus 6 is 1. And bring down this 7. Well, I know from this problem, I wouldn't if I was Bob and not Alice, but for the purposes of what we're doing, 13 can go into 127 9 times. I subtract and I get 10. And I'm going to bring down a 6. Okay, so looks like 9 isn't going to work, but 8 will. Okay, 13 times 8. Here we go. 8 times 3 is 24. Carry the 2. 8 times 1 is 8, plus 2 is 10. So here we've got 106. Oops, sorry, 104. 104. And when I subtract, I get 2. So Bob is going to send that 2 across to Alice. So now, let's review. Alice chose a secret number, works the algorithm, and sends her remainder to Bob. Bob has chosen a different secret number, has worked the algorithm, and sent his number to Alice. Good? All right. So now what I do is I'm going to same numbers here, except for a little different. What Alice is going to do is Alice is going to take that 2 that Bob sent and replace the generator with it. So instead of G to the A, she's going to do Bob's secret number, or Bob's public number that he sent across. And again, all those Eves are seeing these numbers come across, but they don't mean anything to them. So he takes that 2, raises it to her secret power, mod 13. So 2 times 2 times 2 times 2, that's going to be 16. You probably already know this, but let's work it out anyway. So here, Alice is going to take 16 divided by 13. That goes in once with a remainder of 3. Now, if we've done the math right and Alice and Bob have sent their exchange correctly to each other, that means that Bob is going to get 3 when he works out the algorithm. So Bob is going to take Alice's 9 and raise that to 5, his secret number, mod 13. Okay, so basically we've got 9 times 9 times 9 times 9 times 9. It's going to be a big number. Here it is. 59,049. And Bob is going to take that number, mod 13. Okay, I'm going to move this up a little bit so I got some space. So here we go. 59,049 divided by 13. Okay, 13 goes into 59 4 times. Okay, 13 times 4. I'm going to work that out here. You get 52. You subtract, you get 7. Bring down your 0. 13 goes into 70. Look, I have nice, neat work. So that saves me some time here. 5 times, I get a 5. Bring down the 4. 13 goes into 54. Look, I've done that already. 4 times. 4 times 13 is 52. I get 2. I'm going to bring down my last number, which is a 9. 13 goes into 29 twice, which is 26. And 29 minus 26 is 3. Now look, Alice and Bob have come up with the same number after they worked the algorithm. What does this mean? Well, this means that now they have developed a secret key. So this is, say I want to do a simple substitution cipher. A, B, C, D, E, F, G. A moves down 3 places and now becomes D. Okay. All right. So you can go back and watch this as many times as you want to, or pause the video right now. I'm going to show you what happens here when an Eve tries to break in. Okay, so here we go. We've got an Eve now. And Eve is trying to break into this conversation. And what Eve's goal is going to be is really to just pretend to be Bob. So instead of letting all this information go to Bob, Eve is going to choose her own secret number. And she's going to choose, let's say, 3. So Eve is going to pretend to be Bob. and do the algorithm. Now, I'm going to shorten this because we're running short on time. 6 to the third power is 216 mod 13. That means when I take 216, I divide it by 13, I'm going to get some number. So go ahead and try it. What you should get is 8. So Alice has sent across 9. Bob is not going to get it. Eve is going to intercept it. And instead of sending Bob's number across, Eve is going to send Alice the 8. And Alice isn't going to know. So instead of doing Bob's exchange, which worked out nice and neat, Alice is going to use Eve's number instead because she thinks Eve is Bob. So here we go. So Alice is going to take that 8 and say 8 to her secret number, which is 4, mod 13. Okay, so 8 to the 4th power, she gets 4,096 mod 13. And when she works out the division, she's going to get a remainder of 1. Okay, remember, Eve has intercepted this 9. Bob doesn't get it. Bob might have no idea what's going on. And Eve is going to take that, that 9 and raise it to her secret number, mod 13. Okay, so what Eve is going to do is she's going to take that 9 times 9 times 9 and get, 729 mod 13. Okay, and when Eve takes 726 and divides by 13, she's going to get a remainder of 1. So now she has intercepted Bob's message from Eve, or from Alice, and did the Diffie-Hellman exchange in place of that with whatever number she wanted, and ended up getting a 1. So now if Alice doesn't know that Eve is an attacker, Alice is going to start sending messages that now Eve can read. But you see, the only way to get the same number is if you do the exchange with each other. So Eve, watching Alice and Bob exchange, didn't get 3. Eve had to break in and convince Alice that she was Bob, and that did not work. Well, if it works, Alice is going to start sharing with the wrong person. So that's how the man in the middle attacks works with the math. But overall, I hope you've had a couple of opportunities now. You've had 1, 2, 3, 4, 5, 6, 7 chances to try out the algorithm. I hope you've paused along the way, but if not, I hope as you are watching that helps clarify. If not, come and see me tomorrow. Okay? All right, have a good night.